everyone, welcome back to my math teaching online again. Today is a snowing day. It's beautiful looking through my window. On the silver flakes stay on the top of the pine trees. Create a stunning picture through my window. Breathtaking. I love nature. I love nature as much as I love math. Actually, a lot more. Anyway, in our lesson today, I would like to talk about the polar curves, and I will show you how to sketch the polar curves. Let me remind you about my website. If you would like to visit my weekly lesson, I post it there in my website for free education online. You can learn a free weekly lesson. Beside that, I also post some beautiful videos and some interesting pictures, as well as some of my poems from other authors or poets. But I also wrote one or two poems on my own in English. So welcome to take a look, visit at my website if you feel curious about that. The next, you can get into my school online, which is Economy Mathematics Education Online, and you can register to the full set of course, calculus course, and I wrote it here, math courses -online.teachable.com. So from now on, for each video, I will remind you about this all the times. Now, the topic today, I will introduce to you some of the names of the polar curves before I lead you to the lesson. So on my handwriting, you can see we can have a very simple curves, and we call this like a circles. We also have a curve look like the heart shape, and this curve we call a cardioid. The name like a heart, cardioid, and you also can have a lemma cone with how look like this, and you also have a lemma cone with the inner loop. So these are the names and the shape of the polar curves. On the back, you can see this one we call a lemniscate. And down here, look at this rose. We call it rose because it look like a flower, so we call it rose curve. And you can have a even rose curve and with the even petals, and the arc with the arc petals for the rose curve. And the last one, we call a Archimedes spiral. I'm not sure if I pronounce these curves accurately and correctly, but anyway, I introduce to you their names and their shapes generally. So get into the lesson. I will show you how to sketch the two curves today. And the first one, this is my hand sketching, and I will upload this if you register to my course, of course. And you can see on the back is a lot of my handwriting. So it looked like a tedious task a little bit. However, if I show you on the board, you get the idea. It's not so bad. But when you when it's written down, right? I show you because the way I wrote, I show you step by step how you go forward, in what direction, where the angles come from, and what the scale of the angle theta, and so it looks like complicated. And this is the sketching of it, right? Another one I will introduce you today, this curve, sketching polar curves. This is the r equal to sine 3 theta. And I will show you how to sketch them, maybe in the next video, because we will not be able to cover them in one video, right? So stay tuned for the next video. I will show you how to sketch these two curves. Now, when you're sketching these polar curves, you have to know the unit circle. If you know the unit circle and you know how to scale them properly, it's not so bad to sketch them. So let's get yourself be familiar with the unit circle, and also some of the main feature like quadrant 1, quadrant 2, and like some of the coordinates of the trigonometric function, right? If you at this level, you already learned trigonometry in Math 12, and I will make the Math 12 with calculus in the next online course. After the calculus course, pre-calculus. So I go down on the top, right? So I go from calculus and then go to pre-calculus Math 12. Online course, I will develop that, create it and develop it as well. After this this unit, it's going to take me at least another week to write on the exam for you on the quiz and practice exam and solution before I can publish it. So probably I will be absent from YouTube for a while to take care of my online course, but I will try to get back to you and miss on my audience. Now I know all of you around the world. I don't know your name, but I could imagine how my students are, my audience are around the world. We have global education online. Perfect, beautiful. I love you too. Okay, so let me show you how to do the unit circle, right? So on a unit circle, like you scale just like x and y axis, right? But here is like we're talking about the angles, polars, polar read, like a coordinates read, right? So you know that it starts always 0 degree or 0 radian, right? And 0 radian is always stuck like that. So I put a little r on the top, okay? So this is 0 radian. Now in this polar unit circle, and I will talk about not the number like 60 degree or 30 degree, but I will talk in radians, everything in radians, right? So this is just the review section for you, but I want to show you how to sketch the unit circle easily, right? Quickly and easily. So here, if you have a 90-degree angle, obviously, you have square, right? Represent 90-degree angle. And here is 0 degree, and this line is pi. If you draw a half circle all the way from here to here, that will be 180 degrees and equivalent to pi. So this pi will divide by half, right? You can see this line divide this pi by half. And therefore, on the top of this, we call an angle pi over 2, which is the same like 90-degree angle. So pi over 2, because this pi divide by half, and that pi over 2. So if we divide this by half again, so I'm going to mark the dot here, and I'm going to draw another square down here and another dot here, so that I can draw a line going through this, like divide this by half, right? So this line will divide this by half. And because it divides this by half, so I call this is pi over 4. It's line, right? Pi over 4. So here you can count 1 pi over 4, 2 pi over 4, it means all the way from here to here is 1 pi over 4, 2 pi over 4. So in the other side, you will do the same. Let's say you do the same, right? You divide this by half again. So if you divide this by half again, you will have this line. And this line, each of this portion will be pi over 4. So you count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And you can see that 4 pi over 4 divided by 4 is pi, right? So this is 3 pi over 4. 1, 2, 3. So this is 3 pi over 4. So this is 4 pi over 4, 5 pi over 4. So I'm going to mark this line is 5 pi over 4. And of course, this is 6 pi over 4, which is reduced to low fraction, is 3 pi over 2. So this line, 3 pi over 2. So here, 5 pi over 4, 6 pi over 4, and here is 7 pi over 4. So this is how you divide the unit circle, right? It's not too bad, actually. Now, I'm going to, instead of divide this by a quarter like this, let's imagine if you have a half circle on the way from here to here, right? Maybe I should draw it. So I'm going to draw a half circle like this, right? So if you divide this half circle by 3 parts, 3 portions, the whole thing here is pi angle, half of the circle is pi angle. You divide by 3 portions, so you will mark it 3 portions. So it's like this, right? Yeah, so you mark 3 portions, so each of them you call a pi over 3. Now down here will be similar. So for this line, so each of this line, I will call pi over 3. It means the angle on the way to here is pi over 3 angle to the arrow here, right? You see pi over 3 angle. So it means on the way to here is the angle of 2 pi over 3. And this one here is 3 pi over 3. So 3 pi over 3 divided is pi, right? It means this one will be, another pi over 3 will be 4 pi over 3. And on the other side, I will do the same. So I draw this one. Oh, wait a minute. I haven't drawn this one. Sorry about that. So I'm going to draw so this part will be like this. So on the way from here to here actually is 2 pi over 3, and this angle from here to here is 3 pi over 3, right? This one here, 3 pi over 3. And on the way from here to here is 2 pi over 3. I'm missing this one before. Okay, so you can see that this half circle divided by 3 portions right here. 1, 2, 3, right? So this is 1 pi over 3, and this is 2 pi over 3. And down here, if I draw accurate, I should draw accurate. Go to the origin. Should go to the origin. So I'm going to draw this go through the origin accurately. this, we'll create the curve. So this is 2 pi over 3, 3 pi over 3. This one will be 4 pi over 3. And this will be 5 pi over 3. 5 pi over 3, right? So that's the 5 pi over 3. So now what else do we need to know about unit circle? We have another angle which we should also know it. Let's say if this half circle here, I divide by 6 parts instead of 3 parts, it means the pi over 3 here will divide by half, right? So I'm going to divide this angle by half, right? I mark the dot halfway. As well as this angle will be halfway. As well as this angle will be halfway. You already have right through here. And this will be halfway. And this one will also be halfway. Okay, so if I draw like this, I divide this by half again. The pi over 3 divided by half, right? And let me put it short. And this one, 2 pi over 3 will divide by half as well. So at this arrow, the angle from here to here, right, will be pi over 6 angle. I mark here pi over 6, right? The angle, little angle here. So as well as this one, from here to here. So let's count. We have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Pi 5 over 6. So this angle here is 5 pi over 6. And of course, down here is 6 pi over 6, and then therefore it becomes pi, right? So this little angle here, right? This one here, the shaded angle here, right? So 5 pi over 6. Now this one is 7 pi over 4. So on the way this way, this little angle here is 11 pi over 6. If you count it, you will get it, right? So here is 6 pi over 6, and this guy is 7 pi over 6. So 7 pi over 6. So this little angle here, right? 7 pi over 6. And 7 pi over 6, and then 8 pi over 6, and 9 pi over 6, and that's why it becomes 3 pi over 2, 9 pi over 6, 10 pi over 6, and 11 pi over 6. So that's how you draw the unit circle. Now, if you want to draw a circle, right, it will look better, it will look nicer. But you know what? Maybe I use this one from the diagram I'm going to show you here, so let's leave it for now. Instead of drawing a circle, it will look a little bit better, right? If you draw a circle like this, a full circle like this. But that's how you scale the unit circle. I just want to show you how to scale it probably, right? All right, what is next? The next thing, I will show you how to draw the curve of, oh, I wrote it here already. R equal 2 plus 4 cos theta. So how do we draw it? How do we get the shape look like this? Let me show you. So first you have to know, let's say you start from, in order to plot the points on any coordinate grid, we have to know the value of the points, right? So that we can plot. And that's how we calculate it here. Now I can put it, usually we put on the table So what is the R value and what is the theta value? R is the radius value, right? That will lay out a lot better for you to see. However, it doesn't help you in the way of calculation. So I will write it down just so that I can show you how to calculate it on the calculation. So it look a little bit not pretty as the way you see usually in the textbook. They lay out what is the value of R and do column and do row and something like that more beautifully. But I just prefer this way so I can show you how to calculate it as well. Okay, so let's follow this. We're going to draw this curve R equal to adding 4 cos theta. So let's say if we have an angle theta equal 0, we always start from 0, right? Then we calculate the R based on this. So R will be equal to adding with 4 times with cos of 0. And cos of 0, if you learn trigonometry, you know this value, right? If we sketch like this angle here is 0, the same like 2 pi. This angle here is pi over 2. This angle is here pi, and this is 3 pi over 2. And this is the typical coordinates. If we learn trigonometry, 2 things we should need to know. The first one is the unit circle. How to scale it like that, I just show you. And the second one, these are the typical coordinates you should pay attention. So at this point, we have a 1 and 0. 1 stands for cos and 0 stands for sine. Here we have minus 1 and 0. And here at pi over 2, we have a coordinate of 0 and 1. And down here, the same, 0 but minus 1. So these are the typical coordinates we should always remember, right? So cos of 0 is 1, right? This equals 1. So it means to add 4 times 1, which is 6. So now you see the value of theta. If theta equals 0, R equals 6. The radius here equals 6. Now let's say if theta equals, the next, I'm going to use the pi over 3. Now the way I scale, I can use pi over 6 and pi over 4, exactly the same angle like that as well. However, we will have a lot of scale and which is not necessary. So maybe we just choose some typical scale so we can plot the point and we can draw it, right? Of course, the more points we plot, the more accurate picture will be. But in order to save our time, sometimes we want to jump, right? So I'm just omit some of the angle in here instead of do one by one. Now, it's nothing wrong if you do one by one, right? You can scale pi over 6 and then pi over 4, just like the unit circle as well. There's nothing wrong with that. But I just want to shorten the time in the video. So I just use pi over 3 here, okay? So I'm going to say theta equals pi over 3. I'm going to skip pi over 4 and go to pi over 3. So R will be equal to adding with 4 cos of pi over 3. And cos of pi over 3, which is 60-degree angle, which I draw this line, right? This angle is 60 degrees. Opposite of 60 degrees square root 3, this is 2, this is 1. So cos of pi over 3 equals 1/2. So 2 add 4 times 1/2, which is 2 add 2 equals 4. So now I'm going to frame this. So at pi over 3, we have a radius of 4. Now, if theta equals pi over 3, then 2 pi over 3, right? We want to do mirror, right, of the mirror coordinate, right? So 2 pi over 3, then R will be equal to add 4 times cos 2 pi over 3 equal to adding with 4 times cos 2 pi over 3 is this angle here, and exactly the same, which is minus 1/2. So time with minus 1.5, which should make this coordinate become minus 2. So 2 at minus 2 is 0. So at 2 pi over 3, which is this angle here, we have a radius equals 0. So now, let's say if theta equals 2 pi over 3, so now let's go to pi, right? Say if we have pi, then r will be equal to, adding with, pi will be 4 times cos of pi, and cos of pi is minus 1, which is 2, adding with 4 times minus 1, which is minus 4. Minus 4 add 2 is minus 2. So now we go to theta equal pi, right? Oh, pi we go up to here already. So the next, we're going to choose 4 pi over 3. 4 pi over 3. So r will be equal to, at 4 times cos 4 pi over 3, which is 2, adding with 4 times with cos 4 pi over 3, which is this way. And again, this will be minus 1/2 as well. So that will be 2, adding with minus 2, which is give us 0. So at 4 pi over 3, we got that. Now let's count 5 pi over 3. Theta equal 5 pi over 3. R will be equal to, at 4 times cos 5 pi over 3. As cos pi over 3, this angle here will be minus 1 here. No, sorry, minus 1 square root 3, this is 1 and 2. So it will be 2, adding with 4 times 1/2. Right, cos of pi 5 pi over 3, which is this angle here, is 1.5. Cos equal adjacent over hypotenuse. So adjacent is 1, hypotenuse is 2, so 1/2. 4 times 1/2 is 2, 2 add 2 is 4. Now, if theta equal to pi, what happened? R will be equal 2, adding with 4 times cos of 2 pi, and cos of 2 pi is 1, right? Cos of 2 pi is 1, so 4 times with 1, so that equals 6. Now you can see that these mirror coordinates look like mirror coordinate as well, right? So you have 0, then 4, 6. Then down here you have minus 2, 0, and 4, 6. Now, I think if we have a minus 2, we should have a 2 value. Where is the 2 value we're missing? So if we have a minus 2 here, which is theta equal pi, okay, so r equal 2 times 4 cos of pi. Cos of pi is minus 4. Minus 4 add 2 is minus 2. So then we're missing another 2 because they should be mirror each other. Let's see which one is the 2. 2. So let's say minus 4. Theta equals 0. Okay, so if we have pi over 3, then go to theta start from 0, then go to pi over 3, then 2 pi over 3, 2 pi over 3, then go down to pi, and go down to pi, then go down to pi, and then go to 4 pi over 3. 4 pi over 3, 4 pi over 3, we have 0, and then go to 5 pi over 3, we have 4, then 6. Okay, just let's guess this and see what happened, okay? So let me show you how to get this. Now I'm going to keep the unit circle here to keep track of it, right? So let me show you how to sketch this one. So let's say we have this here, and we're going to have the angle of pi over 3, so I'm going to divide this into 3 parts. So this give me pi over 3, and this. This will give me a little bit off, right? So this is 2 pi over 3, right? And this will be 5 pi over 3. And this line will be 4 pi over 3. And this will be pi. Okay. So we start from theta equals 0, r equals 6. Now remember, each line here is the radius of the unit circle, right? So let's divide this by 6 units. 1, 2, 3, 4, 5, 6. So this is 6. So when I plot the point at theta equals 0, we plot the point r equals 6. So the r is from here on the way to here. And let's put the arrow so that we know the direction we go, right? If theta equals 0, we start from 6. Now we go from pi over 3, which is this line, this radius. And we're going to scale exactly the same like this. So this is 1, 2, 3, 4. So here is 4. And at pi over 3, we plot the point 4, right? At 2 pi over 3, which is this radius, at 0. So we don't need to worry about that. It go back to 0. So this is the direction. So the arrow go to 0 here. Now at pi, it go to -2. So just remember, like in physics, right? We're talking about the distance or displacement. The distance is the radius, which is positive on the ties, which is the length of the radius. It's always positive. However, when we're talking about displacement, we're talking about negative direction. If you go to the left, we have a negative. Go to the right, we have positive. And therefore, if we're talking about the direction, then the r here have a negative direction, which is we go backward instead of forward, right? So the radius here will have a negative direction, go backward of -2. So that is the case. It doesn't mean the r here is negative, but it's like negative in direction, right? So we go backward 2 units, which is 1 here and 2 here. So our point ended up here. We go backward because the angle pi is we go forward this way, right? On the left, but because we go backwards, so it go on the right. Because backward compare with the angle, right? So compare with the angle, it's supposed to go forward like this way, 1, 2, but we go backwards, so 1, 2. So the point right here. And let's put the arrow this way. That's our direction. And then at theta equals 4 pi over 3, we go back to 0. So the arrow this way, we go back to 4 pi over 3, 0. Now theta equals 5 pi over 3, we go to 4. So this is the line, right? This is the line. we're going to mark this for 4 unit. So 5 pi over 3, going to mark 1, 2, 3, 4. So at 5 pi over 3 at this angle, our radius is this way. We mark that. And then for 2 pi, it go back to 6, which is this one. So now let's plot it, right? So we start from theta equals 0, we start from here. Then at pi over 3, we go up to here. So this is our direction, right? So we go from here on the way to here. Now at theta equals pi over 3, we go to 4. Then theta equals to pi over 3, we go back to 0. So in order to reach this angle, you have to go on the way from here to here to reach this angle. However, when you reach this angle, you go down to 0, right? And that's why the direction look like this. Go down to 0, okay? Go to 0. So now we go to -2, which is, we go from here, instead of go here, right? We go backward, which is this. Go backward. So -2. And then at 4 pi over 3, because we on the direction like that, so to go back to 4 pi over 3, we have to pass this line, but we'll go to 0 instead, right? So this is the angle. You go on the way up to here to this line, but you go back to 0. And that's why it have a look like that. So 4 pi over 3 go to 0. So now, after 4 pi over 3, you go up here, but you go to 0. Then you go to 5 pi over 3, you go to 4. So from 0, you go to 4, this. And then from 4, you go to 6. So from 4, you go to 6. So here, that's how the shape of the Lima cone in the look like. How it looks like, right? And we call this is a Lima cone. Now I think that we spell it as C, but I think we pronounce it Z, S. So we call Lima zone in a loop, Lima zone in a loop. I tried to pronounce it. Lima zone in a loop, I think. So that is the shape of how we sketch this. And you can see that on my paper, on my paper here, this is exactly look like. Right? So the way I show you on the board, exactly the way I show you on my paper. So if you register to my course, you will have access to all of this. The reason because if you watch the YouTube, right, you can learn it. However, you will forget. But if you register to my course, you learn it in the way that you have a material, leave it for you, right? You have a material, leave it for you, and you will not forget. So you have it there, and you look at your notes, you review, because learning is rehearsal. Learning is usually I think that the best thing it retained for me when I learn is when I review the material, not when I learn. When I learn, I just try to process the information. But how do I retain it? I remember it is when I review it, right? So that's why we have a quiz and we have a test, we have a homework, so that we can repeat what we learn. We can rehearsal. Learning is a rehearsal. Doesn't matter what subject you learn. Music is rehearsal as well. The first time you sing, you will never remember the lyrics. and you will never remember the tunes of the music, up and down, right? But as long as you repeat it again and again, you will remember. So math is just like music or like any other subject. You have to rehearse, you have to relearn. And therefore, when you register to my course online, you have the material there. You can rewind the tape, you can rewind the live video lectures, you can have on the material, you can have a notes, and you should review the notes to remember at least some of them. Not all, no, nobody can retain in our mind 100%. And usually I know that a lot of people criticize about traditional learning, like root of math, like learning. For me, I believe that on the subject require a little bit of memory. Now you not only need to remember them, but you have to understand them for sure, no doubt about that. For math, you have to understand as well. But after that, just like history, just like English, you need to retain a little bit in your memory, right? So actually, I don't criticize traditional learning root memory, to be honest with you. In my experience, right? And I believe that because even though in language, you learn the language, you learn English, you have to memorize what is the shape of the table look like, and you repeat yourself, table, chair, the chair, right? The board, whatever, the clock, you have to remember somehow. In history, you have to remember what years the Second World War came from, happened, right? And therefore, in any subject, including math or computer science, you have to have a little bit of memories. And that is nothing wrong with that. Now, maybe you can see that it's boring, right? It's not creativity, but we have it on in our subject. Even though in ballroom dancing, you have to remember cha-cha-cha, 2, 3, 4, 1, 2, 3, 4, 1 to go forward or backward, right? So any basic thing, you have to have some kind of memory retained in your mind, and nothing wrong with that. So I don't criticize math as a traditional learning route memory. I think that we need to combine on the way of we learn and combine on the teaching strategy together. It both to combine both constructivism, creativity, constructivism, and instructional teaching. We don't just go for one, forget the other. We should combine, right? Once we should use this tool, and another time we use another tools. And how we use it in an effective way, that's the way I'm thinking. That's the way, in my opinions, on the teaching strategies are good, whether it is traditional instruction or creativity, constructivism, or we should combine all of them. Now, in mathematics, if you haven't got the basic idea of foundation correctly, and you try to construct in the wrong way, this doesn't help. It's just wasting your time to try to invent something wrong. Even though you can call it the creativity or not boring, not tradition, constructivism, you build your thinking, whatever you want to mean it. But if you build it, you construct it in a wrong way without the basic foundation of correctly in math, then it doesn't help. It will be waste of your time for inventing something like that, right? Because the same like ballroom dancing, you have to know the basic step very well to create more and more beautiful step, fantasy, right? The beautiful steps. But without the basic, without the root of memorizing 2 times 2 is 4, 6 times 3 is 18, then we construct it in the wrong way. And in math, there only one answer correctly. There only one correctly. So if you construct it in a wrong way, that is wasting time. That is a waste. And that's my opinion about mathematics in my own learning experience. Therefore, I don't criticize any teaching method. I think that we should select, we should combine, and we should sometimes use these tools, another time we use another tools. And we should make a choice when we should know how to use it. And that is the job of teacher, right? Teacher will know what they cope with, what kind of level of student, and they can cope it, and they can make their schedule, their points of teaching, their views of teaching based on what they experience. So I trust teacher in the classroom. Only the teacher is the one who know how to teach the student in the right way. Maybe this tool they should not use for this set of students, but they will use another instruction in teaching for another set of students. And they will use constructivism tools for after going through the basic technique. So anyway, I put in a little bit of food for thought for our video. I know that it's not in the lesson, and forgive me for my talkative sometimes, but I think that it's a good food for thought. Whether you agree or you don't, you disagree, we should know on the opinions of of students and teachers, right? So anyway, I hope that you enjoy this video, the way I show you how to scale the plotting the coordinates, the unit circle, and plot the polar curves. R equal 2 plus 4 cos theta. So this polar curve has the equation of, this is the equation. So just like the x and y coordinate grid, anytime you plot the curve, the wavy curves, the parabola or cubic curves, you have the equation. So in our polar, we also have the equation here as well, right? To plot this curve. And this equation is r equal to at 4 cos theta. That's the curve look like. So I hope you enjoy, and I will end the video here, and I will show you another video to show you to sketch another polar curve. And after that, I also will show you how to sketch them in a short way. But before learning short way, I would like to show you the long formal way first. And then after that, we can shorten it, right? Okay, so thank you for watching my video. I hope you enjoy, and see you in another video.